Okie doke. It is time for us to do a quick review of one of everybody's favorite topics, logarithms. Logarithms are one of the things that students struggle with so much in high school algebra, so I'd like to give you some of the tools that you will need to successfully navigate the last 2 years of high school. That is, in fact, my biggest goal for this video session. I want to show you the tricks behind logarithms. And by tricks, I mean I'd like to show you what the definition is as we have come to define logarithms. We have come to define logarithms in this day and age in terms of exponential functions, exponential equations. So when you see an expression with a log in it, the log always happens with respect to some base. The logarithm is always taken with respect to some number, and the logarithm is always equal to some value. This value is actually the logarithm. Now, what a lot of people remember is that a logarithm is an exponent. It is an exponent, and I shouldn't put that in quotes. I should put that with stars around it, because a logarithm is an exponent. When you see this log statement, what that really is equivalent to is that is equivalent to the exponential statement a to the power of x is y. A to the power of x is y. The base to the exponent is the number. Now, some people in their definitions on logarithms, some people don't use a and x and y. They use b for base, n for number, e for exponent, and then this log statement is equivalent to base to the exponent is the number. Base to the exponent is the number. And in this case, we refer to the rule as the then rule for reasons that totally escape my thinking entirely. But it's important to know how to look at logarithms in terms of exponents, because I might ask you to evaluate the log of 32 base 8. And if I ask you to evaluate the log of 32 base 8, you may say to yourself, whoa, wait a second. The log of 32 base 8 is equal to some number x. And I know, here's the base, here's the number, here's the exponent. Base to the exponent is the number. And then I start running through my powers of 8. And the problem running through my powers of 8 is, go ahead, 8 to the first is 8. 8 to the second is, oh my, that's too big. And so I know that my answer is between 1 and 2, but where between 1 and 2? And then it becomes helpful for us to look at both 8 and 32 as powers of 2. 32 is 2 to the 5th. 8 is 2 to the 3rd to the x. Well, you and I both know from a previous lesson that when you have a power to a power, those exponents multiply. And so if 3x is equal to 5, x is 5/3. But the key here is to be able to convert between this and this. If you can make that conversion back and forth, you will stand a much better chance of solving log problems correctly. Log of 32 base 8 boils down to an exponential equation. So what happens if you're trying to evaluate the log of 32 base 7. If you're trying to evaluate the log of 32 base 7, you're thinking to yourself, well, I know how this goes. I saw the guy do this. I know what's happening here. I'm going to say that the log of 32 base 7 is x, and I'm going to say here's my base, this is a number, this is the exponent. Ben rule says 7 to the x is 32. And you're going to run your powers of 7, and you're thinking, nah, that's not working. And then you're going to try to break 7 down into powers of, nah, that's not going to work. And so at this point, it would be nice for us to have a formula that is helpful. And the formula that is helpful is the change of base formula. If I have some base that I don't know how to work with, I don't know how to work with it at all, but I might know how to work with some different base. I just take the log of c in that base that I know and divide it by the log of b in that base that I know. Well, why is that helpful? Well, that's helpful because in this case, I don't know how to work with the base 7, but I have a calculator that helps me work with the base 10. So I'm going to say that if I have my calculator handy, this thing right here is equal to the log base 10 of 32 divided by the log base 10 of 7. And when I divide those two, I get approximately 1.78 to 3 significant figures. 1.78. And that makes sense because 7 to the first is 7, 7 to the second is 49, 32 is between those, 7 and 49, and so the log has to be between 1 and 2. Things you should practice. You should practice on your own. The log base 2 of 64 is equal to x. I want to know what x is, and then I want to know what x is if the log of 81 base x is 4. And to do that, you're going to have to use the Ben rule to convert, and that'll be fine. The thing about logarithms, because they are exponents, because logarithms are exponents, they obey the same laws that exponents do. And if you know your laws of exponents, you know your laws of logarithms, and if you know your laws of logarithms, you know your laws of exponents. There are 3 in particular we should talk about. 1, if I have a log in some base of a product, well, logs are exponents, so when we multiplied powers of the same base, we just added those exponents. We added the exponents. When you multiply powers of the same base, you add the exponents. These logs are powers of the same base. Similarly, if I have a quotient, the log of a quotient, well, when we divide powers of the same base, those exponents subtract. Okay. And then third, if I have a log of some number to a power, some number to a power, well, this is just repeated multiplication, m times m times m times m times m, p times. And so that's just log of m plus log of m plus log of m plus log of m, p times. That's just p copies of the log of m. Those rules matter because let's suppose that the log of 3 is a, and the log of 5 is b, and I want to express in terms of a and or b the log of 15, the log of 25/27, the log of 27, and the log of 5 base 3. Let's suppose I want to do those 4 things. So what do I have here? I've got the log of 15. How do I get a 15 from a... There. How do I get a 15 from a 3 and a 5? I get a 15 by multiplying 3 and 5. And if I multiply the 3 and the 5, I add their logs. Their logs add, because when we multiply powers of the same base, we add the logs. What's happening over here? 25/27. This is the log of 5 squared over 3 cubed. So I'd like to take the log of 5 squared and subtract the log of 3 cubed, because when we divide powers of the same base, we subtract their logs. Well, how do I do that? I know what the log of 5 is, so this squared comes right down in front, and this cubed comes right down in front, and I've got it like that. A log of 27, that's easy enough. A log of 27, that's the log of 3 cubed, and we already figured that out, didn't we? That's 3a. And then the log of 5 base 3, well, I don't know how to work with the base 3. I know how to work with this base, which is assumed to be 10. And so I take the log of 5 in that base 10 and divide by the log of 3 in that base 10, and that turns out to be b over a. It is fairly standard high school algebra work to expect a student, it's normal for us teachers to expect a student in high school to be able to go from this kind of a scenario to these expressions, to express these logarithms in terms of logs of prime numbers. A couple of things you should know how to do. You should know, oh, should I do one more? Yeah, I'll do one more. I'll do one more before I give you the thing to worry about. Let's simplify log base b of, oh, this will be good, the square root of x times y squared over z. Oh, let's do square root of z to the 5th. Let's do that. Oh, that's good. Good one. Good one. So what do I do in this scenario? Well, I know I've got a quotient, and when I've got a quotient, I know I've got to subtract 2 things. I've got to subtract the log base b of radical x times y squared and the log base b of radical z to the 5th. But, oh, wait a minute, that's a product. So now I know that I can add these logs together, so I've really got the log base b of radical x plus the log base b of y squared minus the log base b of radical z to the 5th. So I'm thinking, I know what happens with this 2. This 2 is going to come down in the front, and I'm going to get 2 log of y base b. That's not a problem. The question is, how do I get a radical to come down in the front? Well, I've got to think about what power is the same as a radical. Do you remember what power is the same as a radical? I hope you said that one. I hope you did. And then I've got to think to myself, how do I get a radical and a 5th power to come down in front? What is the fractional exponent that raises to the 5th power but takes a square root? And that appears to be this one. And so if we were to expand the logarithmic expression in such a way that we're not dealing with radicals and powers, but we're dealing with just log of x, log of y, log of z, this is the way we would do it. So, things you should know how to do. You should know, let's move this down. If the log base A of P is X, and the log base A of Q is Y, express the following in terms of X and Y. The log base A of P squared Q cubed, and the log base A of radical P over Q. That is something you should know how to do, how to tear it apart so that we're looking at just the log of P and the log of Q. You should also know how to do this. If the log of 2 is P and the log of 3 is Q, find in terms of P and Q the log of 9, the log of 54, and the log of 32 base 9. Log of 32 base 9. Those are things you should know how to do. That is a really quick review on the basics behind logarithms. I hope you enjoy it, and we will see each other soon.